This is section 6.4. This is part 3 of your rational exponents groupings. Okay, and today we're going to talk about putting all these things together with all your rational exponent rules, breaking down and changing forms from exponent to radical, rational exponent to radical and radical to rational exponent, and being able to simplify some of these. Okay, so part 3 here, combining and simplifying radical expressions and rational exponents. First thing we want to do, convert to rational exponent so that we'll be able to simplify the roots. Remember, if the roots are not the same index and have the same number, we really can't do much with them. Okay, so our goal is going to be to change everything to rational exponents, otherwise we won't be able to simplify it. Okay, then we're going to use our rational exponent rules, or our exponent rules, same thing that they've been, okay, to simplify the expressions. Your answer will not have rational exponents in it. This is very important. Okay, it's not going to have any rational exponents. You must be radical expressions to be simplified. Okay, all right. So let's take a look at some examples here, and let's take a look at this first one here. What is the fourth root of x to the third over the eighth root of x to the second in simplest form? All right. So first thing that we look at here is we want to change forms. Change them to rational exponents. So the fourth root of x to the third is really x to the 3/4 power over x, or the eighth root of x to the second is really x to the 2/8 power. Well, I can reduce 2/8 to x to the 3/4 over x to the 1/4. They're both divisible by 2. Okay. Now, I notice that my exponents have the same bottom, essentially, and I have division. So with division, what do we do with our exponents? We subtract them. So this is x to the 3/4 minus 1/4. Well, 3/4 minus 1/4 is 2/4, so x to the 2/4. Reduce that, and that's x to the 1/2. And now remember, I cannot have any rational exponents I cannot have any fractional exponents at all in my answer. So I need to convert this back. And if I convert this back, this ends up just simply being the square root of x. Okay? So we can simplify roots that don't have the same index or don't have the same variable or number underneath by changing them to rational exponents. Okay, now let's take a look at, again, a couple more examples here. Let's start with letter A, and let's take letter A here and make it a little bit bigger so we can see, and we got some space now. We've got negative 8x times the square root of xy all to the 2/3 power. Okay, so first thing I'm going to do is I'm going to distribute the 2/3 to this radical, to the x, and to the 8. So I really have negative 8 to the 2/3 times x here to the 2/3 power times, and if you want to treat this, remember xy, this xy should really be to the 1/2 power. Because remember, it's a square root underneath of it, so I need to change the root to a fractional exponent. I probably should have done that first. So I'm going to take that 1/2 times 2/3, which is going to end up being an xy to the 1/3 power, because these two 2's here will cancel. Okay, so now I've got negative 8. I'm going to replace this. Now, again, we talk about these and we talk about these numbers. We want to replace negative 8. I want to replace negative 8 with 2 to the 3rd. So this is really negative 2 to the 3rd to the 2/3 power times x to the 2/3 power. And I can use another distribution here, and then this is times x to the 1/3 times y to the 1/3. So I'm using exponent rules, and I'm also breaking down numbers as well. So you'll notice this is really 2 to the 3 over 1, and these 3's are going to cancel out. And it's really negative 2 to the 2nd power times. These guys right here our multiplication so I can add their exponents. And so this is really x to the 2/3 plus 1/3, which is x to the 3/3 power, times y to the 1/3. Okay? Negative 2 squared is 4. X to the 3/3 is really x to the first, so it's just really x. And then y to the 1/3 is really the cube root of y. And now you are simplified. This right here is your answer. Okay? All right. Now, let's take a look at this bottom left A right here. You'll notice on this one, a little bit different, we have a negative exponent. So a negative exponent tells us that we need to move it to the bottom of a fraction. So this really needs to be 1 over 8x to the 15th, all to the 1/3 power. Okay? So, now when I do this here, again, I'm going to change and break down 8 if at all possible. So if I can break down 8, I'm going to do so. 8 is going to break down to 2 to the 3rd. So this is really 1 over 2 to the 3rd x to the 15th to the 1/3 power. And now we can distribute that 1/3. So this is 1 over 2 to the 3 times 1/3 and x to the 15th times 1/3, which is really 1 over 2 to the 3/3 x to the 15/3. Or essentially, you're dividing the exponents. Well, 3 divided by 3 is 1. So this is really 2 to the first. And 15 divided by 3 is 5. So this is really ends up being 1 over 2x to the 5th power. So we use a couple multiplication. We got a couple rules here with exponents. We use a negative exponent rule, move it to the bottom, and we also use the distribution of the exponent rule when we multiplied and then we divided our exponents out. Okay. All right. Last example I'm going to look at here is our top right example. You can cross this example, letter B, out. We're not going to mess with that one. That one's a little bit different. Plus, it's a screw up on that one. But we do want to look at this one. Okay. Now, anytime you have parentheses on this, again, you want to work inside out. So because this y, and this is only y to the negative 8, the 16 is not to the negative 8. So since it has a negative exponent, I need to move it to the bottom of a fraction. So really this is 16 over y to the 8th to the negative 3/4 power. Start with the inside one first. Now I'm going to use the outside negative exponent. So when we have a negative exponent again, that tells us I either need to move it to the bottom or the top, or if it's a fraction, I need to flip it. So this now becomes y to the 8th over 16, all to the now the 3/4 power, because it's positive because I flipped the fraction. Okay. Now I'm going to go ahead and distribute. The 3/4 is going to come here to the y to the 8th, and it's going to go to the 16. So I have y, 8 times 3/4 is 24/4 over 16 to the 3/4 power. Okay. Again, you'll notice 16 can be broken down. 16 is 2 to the 4th power to the 3/4. 24 divided by 4 is 6, so this is really y to the 6th on the bottom, or on the top. And you'll notice these 4s are going to cancel, so this is really y to the 6th over 2 to the 3rd, and y to the 6th over 2 to the 3rd is 8. And this is your final answer. Okay, so now that we went through this in breaking down rational exponents, radical expressions, being able to go back and forth, okay, this concludes section 6.4 part 3. Don't forget to complete your WSQ when you get finished watching this video.